Okay, so we have the rate of change, and we have the initial amount. So if I have something like this, well, let's just start with the real problem. Let's say I borrow some money to start a business. How much money should I borrow? $10,000. And I'm going to sell, what am I going to sell? Ice cream cones? Can we sell ice cream cones? Okay, how much are we going to sell them for? $5 per cone. $5 per cone. One cone. Do you see how we have an initial amount and we have a rate of change? Okay, we have an initial amount and we have a rate of change. So it kind of fits in this linear equation idea. That's what this kind of linear equation thing is for. All right, so it's kind of tricky, but we'll do it here. So the M, what's my rate of change? Okay, $5 times X. What's the initial amount? Now, that's kind of the basic idea. There's some serious problems with our equation right now, okay, that we're going to have to take care of. But do you see how this is always the rate of change and this is the initial amount, the starting point? Where are we starting? Okay, so you can always know where those two things go. Now, we got problems here. First of all, didn't we borrow this money? So is that a positive amount or is that a negative amount? That's a negative amount. See, we had to buy all the ice cream and the cones and the scoopers and the freezer and the napkins and the cart that we put it all in, that we walk around the park selling ice cream cones. We don't have those here. Maybe someday you'll go somewhere where they do. But anyway, we had to buy all that stuff. We had to make an initial investment, okay? And so we're down $10,000. And this is pretty common. You have to borrow some money to start making something or start a business. And then I'd say the $5 per cone, I'd say that's a positive. You guys agree with that? That's what we're bringing in, right? So this is a little bit better. What are the X and the Y? Is this problem about xylophones and yaks? Is that what we're talking about here? X and Y, piece of junk, X and Y. What's X and Y? That doesn't make any sense at all. What are we talking about here? What are the two things we're talking about?
Y would be your profit, and X would be your amount sold.
Yeah. We got, look, right here in our rate. What are the two things we're talking about? Come on, you can do it. What is this? What is that symbol right there? Here, should I write it more clearly? I heard one of you. Come on, what is it? Money and what else? Ice cream cones. Those are the two things we're talking about. We're not talking about xylophones and yaks. Okay? We don't want X and Y here. That makes no sense in this problem. It makes sense if you want to put it on a graph where the axes are labeled X and Y, but it doesn't make sense for us. Okay? So, what's Y? Is it money or cones? Okay, I agree. Money. And that means that the X has to be the number of ice cream cones. Now, this equation makes sense. That's a real equation. Even though I know we're talking about ice cream cones. Still a real equation. Not X and Y. And can we graph it still? Even though it doesn't have X's and Y's in it? We can graph it? I want you to notice that I have the first quadrant here, and I have the fourth quadrant here. I really didn't make room for the second and third quadrant, did I? Why not?
So we're not gonna be dealing with those.
Why aren't I going to need it?
You're not gonna make your negative cones.
I'm not going to sell a negative number of cones. So as soon as I open up, someone's not going to bring 10 ice cream cones and return them from the week before, are they? I'm not satisfied with these ice cream cones. I'd like my money back.
Even with that scenario, you still wouldn't be selling negative ice cream cones. You just wouldn't be anything.
Who knows? Okay. Now, this isn't the y-intercept. What is it? There's not even a y-axis. What is this axis? And this is the cones. So, does it make sense that, well, I'll just go look. Here's 5,000. Here's 10,000. Each little mark doesn't have to be a 1, does it? No. Okay. We're starting right there. And then every time we sell a cone, what's going to happen? Until we get up to what? Won't it be awesome when we get up to $0?
Yeah.
Isn't that an important thing? See, we always talk about the y-intercept. Oh, the y-intercept. Well, the y-intercept's important because that's my initial amount, right? But the x-intercept is super important too, in this case the cone intercept, because that tells me how many cones I have to sell to get up to $0. That point where I start making money, right? Okay? So, how can I figure that out? How can I figure out where that is? How can I figure out when this number right here is a 0?
Replace that as a 0 and then basically solve it as an equation.
I think that's a fantastic idea. If right there I replace that number with a 0, don't I want to know when it is a 0? Well, put a 0 there. What do you think about that? Easton, does that make sense? Yeah? Now, can we solve this and find C? Sure. What do you want to do? Add 10,000 to both sides. Divide both sides by C. Or sorry, by 5. 2,000? Holy moly, that's a lot of cones. So I'll just do this. 1,000. It's my graph. I can make it how I want it. There's my x-intercept. And then every cone I sell after that, that's profit, correct? Okay. This is what we're talking about. This is what linear equations are about. They're about an initial amount and a rate of change. Okay? Millions and millions and millions of situations involve an initial amount and a rate of change. I have 200 burgers in the fridge. I am selling 25 per hour. What do I want to know? When am I going to run out, right? So I can have more. Because what happens if you own Wendy's and you run out of burgers? Yeah, I went into Taco Bell and Price. And I went to order, and the guy said, before you order, I just need to tell you, we don't have any meat.
You're like, I didn't come to Taco Bell for a salad.
He's like, we have chicken. But no. And I was like, what in the crap? How can that happen? Don't you know about linear equations?
It's like when the McDonald's ice cream machine never works.
Ugh, McDonald's ice cream. You know the best thing about my kids being grown up? I haven't been to McDonald's for like 15 years.
Why?
And that's the best thing? Yeah.
It's one of the best things.
It is.
McDonald's made me want to, kill myself sometimes. okay, we won't get into that. So, there you go. That's what this is all about. That's what we need to do linear equations for. Who learned something today?
I learned that.
Dang it, Kimball, put your hand up! Just give me this. I hope you all learned something. Okay, so quickly on the graphing thing. Anything that starts out y equals is in slope-intercept form. Okay? It might look like this. Okay, where you can see, oh, what's the intercept? What's the initial amount? What's the rate of change? 1/2. Okay. It might look like this. Where what's the initial amount or the y-intercept? 0. Right. Now we're too lazy to write it. Okay, but it's there. What is it? It's Halloween, right? It's the ghost 0. It's there. Okay, it is there. This one. What's the initial amount or the y-intercept? Okay, what's the rate of change? Okay, it's there. We're too lazy to write. We are too lazy to write that, but it's there. Okay? Anything that starts out y equals is in slope-intercept form. The y-intercept might be 0, the slope might be 0, okay, but it's there. If it starts out x equals something, that is not in slope-intercept form, okay, because there is no y-intercept. This one is a vertical line, okay. There is no y-intercept, okay, unless I guess it's this equation. I guess that would go up and down the y. That would be the y-axis, wouldn't it? Okay. But normally there's not a y-intercept, and there's not a slope either. Okay. The slope in this case, think about this. To go from here to here, my rise could be 1 or 10 or 15 or 20 or whatever it happens to be. But what is the run from here to here? Okay. Can you take 20 things and divide them up into 0 groups? No, we can't divide by 0. That doesn't make any sense. Okay, it's meaningless. So there is no slope on a vertical line. The slope is undefined. Okay, to actually get vertical, you have to go up a certain amount and then over 0. So you're dividing by 0. So the slope on every vertical line is undefined. The slope on a horizontal line, so a slope on a horizontal line like this, y equals something. What's the slope in that case? 0. So we're too lazy to write 0x plus 4, right? But that's what we mean. And I think this makes sense because you think about a road that has 0 slope, right? If the slope is 0, wouldn't that just be flat? Like you could just see it going out there forever and it doesn't go up or down, right? Okay. Okay. All right, so that's a start. Now I have a problem assignment on Alex. Let's get that done. Hey, Michaela, come here for a second.
My butt hurts.
Yeah.